At full moon, the moon rises at sunset and sets at sunrise. The idea is that a person here can see the sun set as the moon rises, and a person here can see the moon set as the sun rises. At new, the moon rises at sunrise and sets at sunset. So new moon is the equal but opposite alignment of full moon, which means that for a person here, the sun and moon are setting at the same time, and for a person here, the sun and moon are rising at the same time. Like this. Uh-oh, something's wrong here. Actually, there are a lot of things wrong here. First, we must accept the absurd notion that a person at the top or bottom of this earth could see either the sun or the moon around this ball, when their field of view could only be horizontal, as in horizon. But even if we allow that a person could see around this ball, the angle at which they could see the sun rise or set would not allow them to also see the much closer moon. And if we allow that they could see around the ball to such a degree that one of them could see the moon setting as the other one sees it rise, the sun, at its much greater distance, would be well above the horizon for each of them. By the way, this is the alleged alignment of the sun, moon, and earth during a solar eclipse. So according to mainstream heliocentrism, this guy is seeing the eclipsed sun rise as this guy is seeing the eclipsed sun set. Of course, we know from repeated observation that a solar eclipse is seen on one part of the earth hours before it is seen on the opposite part. Maybe it's because this diagram isn't to scale. Okay. This is the earth and moon to the scale we've been told, with the moon 238,000 miles from the earth. I extended it to about 2 million miles from earth and drew my angles through the middle of the moon from the top and the bottom of the earth. Unfortunately, I had to size it down so far from my screencast-o-matic that the resolution stinks. This is the same earth and moon to scale from that other image. The parallel white lines are the diameter of the earth. The yellow line is the view of a person on top of the earth seeing half of the moon as it sets, and the red line is a person at the bottom of the earth seeing half of the moon as it rises. The sun would be here, aligned with Earth and the same angular size as the moon. But you can see that even with the sun only 2 million miles away, both people who are each seeing half of the moon on their horizon would see the sun well above their horizon lines. And this entire screen represents the sun at only 2 million miles from the Earth. How far will the red and yellow lines of sight diverge from the sun if we extended this screen another 46 times as far to the distance we're told the sun really is? We simply cannot have a sun 400 times farther away than the moon and see them both rise or set on our horizon at the same time. Nor can we have one of them rise just as the other sets, or set just as the other rises. And the problem gets much worse if you add Polaris into the equation. Because although Polaris isn't ever aligned with the sun or moon, we are told that two people on opposite sides of the equator can both see it on their horizon at the same time. If our line of sight angle through the moon was placing the sun far above the horizon at only 8 light minutes away, how far would Polaris be above the horizon at 433 light years away? This isn't rocket science. The idea that people can see around the ball Earth is itself absurd. But if the angle at which we can see around the curve allows two people on opposite edges of the ball to both see Polaris, then they couldn't possibly see the sun or moon from that angle. And if the angle is such that they could both see the sun, then Polaris would be way above their horizon, and the moon would be well below it. If the angle was such that they could both see the moon, then the sun would be well above their horizon, and they'd both be able to see Polaris way above their horizon at opposite sides of the equator at the same time. The heliocentric model simply doesn't work. It's time for a better model.